Hello students, as you all are aware that the traditional classwork has been suspended due to the coronavirus threat, so I have created this online course for my students of BSc semester 2nd of my college, Government Degree College Rajouri, and the paper is C language. Now without wasting any time, I am coming to the main part. We have already completed the 3 units in the classroom. Today I am going to start this 4th unit online. As you can see from the PowerPoint presentation, the syllabus of the Unit 4 includes storage classes, pointers, definition, declaring pointer variable, arrays 1, 2 and multi-dimensional arrays, and so on. Much more topics. And in this very much video I am going to talk about the storage classes used in C language. Now first of all I will define what a storage class is. A storage class defines the visibility or scope and lifetime of a variable. It defines the following things about a variable: that where the variable will be stored, its storage, its default initial value, scope of the variable, that means the functions in which value of variable would be available, and at last the life of the variable, how long variable would exist in the program. Now, before going into the detail of storage classes, let me explain what a variable is. As we already discussed in the classroom, what a constant and a variable. Now we are not concerned here with the constants, we are only concerned with the variables. A variable whose value changes with the execution of the program. So far, as we have done so many programs in the class, in the computer lab, in every program we have declared a variable. So far we have only defined the declaration of the variable. We have declared the variable as integer or character, float, unsigned integer, signed integers, and so on. We have just defined the data type of a variable, and a data type of a variable defines what type of value will be stored in the variable. For example, if we declare a variable as int a, it means the name of the variable is a and it can store only integer values, and the size of the variable will be 2 bytes and its format specification will be %, and so many things, all the things will be defined. But we have not defined yet where the value of this variable will be stored and what will be the characteristics of the variable. All these things, the scope of the variable, the life of the variable, its storage capacity and its default initial value, is defined by defining the storage class of a variable. So whenever we declare a variable in a program, we not have to just declare its data type, but we also have to define its storage class, and so far we have not done that. So a storage class defines the visibility or scope of the variable and the lifetime of a variable, and it defines the major 4 things about a variable: its storage, where the variable will be stored; the default initial value. Storage means the whenever we declare a variable, its value gets stored in the 2 locations, in 2 types of memory. First is memory and second is the CPU registers. Where the variable will be stored, it is get defined by its storage class. Second one, default initial value. Whenever we declare a value, it takes a default initial value that we call a garbage value. Third one is scope of the variable, where the variable will be applicable, means functions in which the value of the variable would be available. And at last, the life of the variable, how long variable would exist in the program or a function. Next, various types of storage classes. There are basically 4 types of storage classes. Number 1 is automatic storage class, second register storage class, third one is static storage class, and the fourth one is external storage class. I'm going to explain all these types one by one along with the examples. First, let us talk about what an automatic storage class is. In automatic storage class, the the features of a variable that is declared as automatic, these are given below. As first feature is storage, where the variable will be stored when we declare a variable as automatic. It gets stored in the computer memory. The storage is computer memory. The second one is default initial value. The default initial value of a automatic variable is garbage value. Garbage value means unpredictable value. Whenever we declare a variable, it takes the value from the memory, any garbage value, and gets stored in that variable. Third one is scope of the automatic variable. The scope of the variable is local to the block in which it is defined. What do you mean by a block? A block means a portion of the program comprises between two curly braces, the open bracket, the open curly bracket and the closed curly bracket. Within that braces, the entire portion calls a block or a function. We can call that a block or a function. So scope of the automatic storage class variable is local to the block in which it is defined. And at last, the life of the variable. The life of the automatic storage class variable is till the control remains within the block in which the variable is defined. I am going to explain this concept along with an example. The example is shown on your screen. We have created a program snippet. It is a small program snippet that explains the working of an automatic variable. We have declared two variables I and G, and we have declared them. Look, there are two things defined. First keyword is auto, second keyword is int. The keyword int defines the data type of the variable. That means both the variables I and j are of type int. They can store only integer values. Their format specification is %d. Their memory size is 2 bytes or 4 bytes. That is compiler dependency. And another one is auto. This keyword is important here. This auto keyword defines the storage class of two variables I and j. They are auto storage class variables. After that, we have printed the values of I and j. Look at the output. The first output is 2350 and second one is 3450. Where these values have come? We have not initialized any values in I and j. We have not input it using an user input using printf scanf statement, and not we have initialized them. From where the I and j have got these values? This is called as garbage value, because we have declared the storage class of I and j as automatic, and it means the default initial value of this variable will be garbage value, unpredictable value that the compiler will take from the memory. This is the automatic storage class. Next one is register storage class. Whenever we declare a variable as a register variable, then the features of this variable will be: number one, storage. Where the variable gets stored? It gets stored in the CPU registers. Look at the difference between the auto and a register variable class. In auto, the variables get stored in the memory, and in register storage class, the variable gets stored in the CPU registers. And second one is in default initial value. It is the same as automatic register class, the garbage value. It takes the garbage value or unpredictable value. Third one is scope. The scope and the life is same as in automatic storage class. The scope is local to the block in which the variable is defined, and the life is till the control remains within the block in which the variable is defined. I am going to explain these 4 characteristics of register storage class along with an example. The example is on your screen. It is also a small program snippet. It's a void main. In the main function, we have declared one variable I as registered int I. After that, we have used a for loop. I is equal to 1, I less than equal to 10, I plus plus. After that, we have printed the value of I. Now this loop runs for 10 times. As this is clear from the condition of the loop, I is less than equal to 10. I is initialized to 1. Loop runs for 10 times, and it will print the output of this small program snippet is 1, 2, 3, 4, 5, 6, 1 up to 10. It will print the numbers from 1 to 10. Now, what is the difference between automatic and register storage class? Look, I have already told you that the register variables get stored in the CPU registers, not in the memory. Now, as you have already studied the paper computer architecture. In that paper, you have studied the things that the CPU registers are very limited in number. There are very small number of CPU registers available in any computer system, laptop or PC or anything like that. So we have to take care whenever we declare a variable as a register storage class. So only if the variable is used frequently in the program, or the variable is accessed many times in the program, only then the programmer should declare the variable as a register variable. Otherwise, he or she should opt for the automatic storage class. As we have in this program used the counter variable. In the loop we have used the counter variable I, and we declared I as a register because it is repeated many times, it is used many times in the program. For it gives the register storage class gives the faster access to the variables as compared to the automatic storage class. So for faster execution, for faster access of the variables, and whenever the variable is used many times in the program, only then the programmer should go for the register storage class. After this, I'm coming to the third category of the storage classes, that is static storage class. In static storage class, the variable is stored in the memory. The default initial value is 0. Now here is the difference between the automatic register and static storage classes. In both automatic and in both the automatic and register storage class, the default initial value was the garbage value, but in static storage class the default initial value is 0. If we declare a variable as static variable and we don't initialize anything into it, the 0 by default, the 0 gets stored in that variable. Scope remains the same, local to the block in which the variable is defined. Life, here is the difference. Life of a static variable is the value of the variable persists between various different function calls. This is an important point, and I'm going to explain this point along with an example that appears on your screen. Look at the code. I have written two different code snippets. In one under the main function, I have called one function increment 3 times. We have defined the same function increment, and I have called this function 3 times through the main. Increment function call number 1, increment function call number 2, function call number 3. After that, I have defined the increment function, in which I have taken a variable I as auto. Means the variable is declared as integer and its storage class is automatic storage class. After that, I have printed the value of I, and after that I have just incremented the value of I by 1. In the second program snippet, the same program goes here. Under the main, I have called the increment function 3 times, and after that I have defined the function increment. Here is the difference in the definition of the increment function of the second code snippet. I have declared the variable I as static. In the first code snippet, the variable I is auto. In the second, the variable I is static. And simply I have printed the value of I. After that, I have incremented the value of I by a value of 1. Look at the output of these two codes. In the first case, the output remains the 1 1 1, and in second case the output becomes, in first increment function call, it prints the value of I as 1. In second case, it prints the value of I as 2, and in third case it prints the value of I as 3. Now where is the difference? In automatic storage class, the variable is every time initialized to 1 whenever the function is called, because it is automatic. The value of the variable, the life of the variable remains only within the function in which it is defined. The variable is defined in the increment function. Whenever the control comes in the increment function, the value of I is initialized to 1 and it prints the value of I. After that, incrementing the value of I goes waste, because it does not store the value of I as 2 whenever the function terminates. In the second case, when the variable is declared as static, the first time when the function is initialized to 1, it is printed to 1, and after that it is incremented by 1, it becomes 2. Again, when the value of the variable I remains the same where it was left in case of static. Whenever we declare a variable static, the value of the variable remains alive, persists between various functions called. That is why there is a difference between the output of these code snippets. Now coming to the fourth and the last type of the storage class, that is external storage class. In external storage class, the characteristics of the variable are: the value is stored in memory. First one is storage. The value is stored in memory. The default initial value of the external storage class is also the 0, as same as the static variable. The scope is global. This is different from rest of the three classes of the storage. Global means the variable is declared before main. Before starting the main function, we can declare a variable like after the header files, we can declare a variable int a, and after that we will start the main function. This a variable will be available to the entire program, entire functions, to the main function and all the functions that will be defined below. And life of the external storage class variable is as long as the program execution does not come to an end. As long as the program does not terminate, the value of the variable exists in the memory. I will explain this concept along with the example. Here is the example. Here I have declared a variable int I. After that, the main function. In the main function, first I have printed the value of I. After that, I have called a function increment 2 times and called another function decrement 2 times. After that, I have defined the functions increment and decrement. In increment function, simply I have just incremented the value of I and printed the value of I. In decrement function, I have decremented the value of I by a value of 1 and just printed the value of I. Now look at the output. In first case, the output is I is equal to 0. Go back to the main program. In the main, the first statement is printf I. The value of I will be printed. Initially I is 0. Why? Because it is an external storage class, and in external storage class the default value of a variable is 0. The value is printed as 0. After increment function is called. In increment function, I is incremented by 1, 0 becomes 1, and the value of I is 1. After that, again increment function is called. The value of I becomes 2. After these two function calls, the third function call statement is decrement. Another function is called, that is decrement, and in decrement, as you can see, the value of I is decremented by 1. Before that, the value of I was 2. Now value of I become 1 and it gets printed as 1. After that, again calling the decrement function, the value of I becomes 0. Now it is clear from the program that we have declared the variable I outside the main function, but we are accessing the variable I inside the main function, and we are also accessing the variable I in the functions increment and decrement. So it is a global variable. It can be accessed from any part of the program, from any function of the program directly, and its value remains as it was earlier. So this was all about the various storage classes used in the C programming language. I hope you get the point. You can get the rest of the information from the book that I have already prescribed you, The Letter C by Yashwant Kanetkar. It has given the entire concept of storage classes in detail. You can consult that book, you can make your notes, and you can also call me or query me through the online group chat. Thank you.